All right, if you were having some difficulty or some trouble with the examples on Locus that we looked at the end of class today, this video is for you because I'm going to walk you through each of these examples step by step, and I'm on page 14 in your notes packet, and kind of explain the thought process or what I was thinking as I wrote my answers out to these. So on page 14, number 1 wants to know what is the locus of all points equidistant from two parallel lines that are 12 centimeters apart. So the first thing I have to do is I have to decide where I'm starting. What am I given? What am I being given to work with here? So my starting place is going to be these two parallel lines that are 12 centimeters apart. So I'm going to go ahead and start by sketching two parallel lines that are 12 centimeters apart. Doesn't matter what the orientation is, as long as you've got those two parallel lines on there. The criteria or the condition that I want to satisfy is I want to find all the points that are equidistant from those two parallel lines. So I'm going to start by going into my picture and I'm going to find just one point that's equidistant. Equidistant, remember, means the same distance from one as it is to the other. So if I go put a little green dot right there, it's the same distance from this green point to the line on the left as it is from the green point to the line on the right. That makes my point equidistant from each of those two parallel lines. I'm now going to go find another point that's equidistant. So same distance to the line on the left as it is to the line on the right, making this point equidistant. Third point here, equidistant to the line on the left as it is to the line on the right. So same distance to both of those lines, making that fella equidistant. Same distance to the line on the left as it is to the line on the right, making that fella equidistant. So now I've got a few points here. I can see that the general geometric shape that I'm sketching is a line, and that's where my locus comes from. So to describe this fella, I need to describe, first of all, what geometric shape it was that I drew. And that was a line. There's a lot of lines out there in the world, though. What makes this line unique? What makes him special? He's parallel to the given lines. But again, I need to give just a little bit more because there's lots of lines out there that's parallel to the given lines. This one is special because it's midway between them. Or you might say halfway. So that's a nice description that describes this green line and only this green line, no others. All right, the next one, number 2, wants to know what is the locus of all points that are 7 inches away from a given line. So I'm going to go ahead and I'm going to start with a line. How did I know I was starting with a given line? Well, that's what was told to me in the picture or in the problem. It said start with a line. I want to now go find the set of points that's exactly 7 units away from that line. So I'm going to say this fella, 7 units above the line, 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 and I can continue on in a similar fashion until I end up with a whole bunch of points that are 7 units above the line. And I can see from what I've drawn that this too is going to end up being a line. Now that said, I found some of the points that are 7 inches away from that line, but I didn't find them all. There's one down here that's also 7 units away from that line. This fella, 7 units away from the line, so on and so forth. So we've got to be careful when we sketch our pictures to remember that we include in our locus all of the points that satisfy that criteria. And at this point, I cannot sketch any more lines or any more points that are 7 inches away from that line. So I know that I've gotten the whole entire locus. So as far as the shape of my geometric figure, what was it that I drew? Well, I drew 2 lines. What's so special about these lines? What description can I give that describes these and only these lines? Well, these guys are parallel to the given line or to the original line. But there are lots of lines out there that are parallel to the original line. I have to really put into words what makes these guys so special. And what makes these guys so special is that that given line is either halfway between them, or I like the word midway between them. So I'm going to finish my description up here by saying with the given line, midway between. I don't know why my pen is writing in invisible ink. So two lines parallel to the given line with the given line midway between. Smartboards have invisible ink now, I guess. All right, and then the last one for this page, what is the locus of points that are 6 meters away from a given point? So I have to identify what it is that I'm starting with here. In this particular case, I'm given only a point to start with. So I'm going to start with a nice big point on my line or on my paper. I want to find now all points. The criteria that I want to meet is I want them to be 6 meters away from that point. Well, there's one over here that's 6 meters to the right, one over here that's 6 meters to the left, one up here that's 6 meters above and 6 meters below. There's one around here that's exactly 6 meters, one here that's 6 meters. This guy is 6 meters. Sometimes a mistake that kids want to make is they want to go all the way up here. But if that's the case, then the distance from that point to the center is going to be a little bit more than 6 meters. So 6 meters would be exactly a circle. So there's my locus of points. The geometric shape that I drew, we set as a circle. And now I need to describe that circle and no others. So I'm going to talk about where its center is. So the center is the given point. And its radius is equal to 6 meters. And that description describes exactly that circle that I drew and no others. Okay, up at the top of the next page, oh, it got cut off in the video, but you can read it on your paper. It says, what is the locus of all points that is equidistant from two perpendicular lines? So I need to first of all begin by what it is that I'm being given to start with, and that is my two perpendicular lines. So I'm going to go ahead and draw those. Remember, perpendicular means meets at right angles. So there are my perpendicular lines. I know they meet at right angles because I'm going to indicate that in the drawing. And I want the set of all points that are equidistant from those two lines. So the same distance to one line as it is to the other. So there's a point that's the same distance to this line as it is to this fella. There's a point, same distance here as it is down to here. Here's a point, same distance to this line as it is to that one. Here's another one. Again, same distances. And I can probably sketch in there a whole set of lines going that way, where it's the same distance from one line as it is to the other. And likewise, there's some points over here that are equidistant from those lines, and some points down here. And again, I can kind of use my pen now. I can fill in the shape of what that's going to be. All right, so now I have to go ahead and describe exactly what it is that I drew. So the geometric shape is two lines. But again, there are lots of lines out there. We need to describe what makes these special. So these guys are actually the bisectors of these angles that were formed by the original lines. That's probably the easiest way to describe them. So the bisectors of the angles formed by the original lines. All right, and then the last one from class today wants to know, what is the locus of all points equidistant? Wait, what does that say here? Equidistant from two fixed points that are 1 foot apart. So the first thing I need to do is identify what it is that I'm being given to work with. So my starting place is going to be those two fixed points that are exactly 1 unit apart. So I'm going to make the distance between those guys 1 foot. And I want the set of points, the criteria that I need to meet is that they need to be equidistant. So the same distance to one of those black dots as it is to the other. So that red fella, same distance to the black dot on the left as it is to the black dot on the right. He's equidistant. This guy up here, same distance to the black dot on the left as to the black dot on the right. This little red fella is equidistant. There's one down here who has the same distance to the black dot on the left as is to the distance to the black dot on the right, making this red dot equidistant. This guy, equidistant. This guy, equidistant. I might be tempted to go put one up there where I put the blue one, but this blue one is closer to the black dot on the left than the black dot on the right. He's not equidistant, so he can't be part of our locus. But you can tell that our locus now is starting to take shape, and we end up with a line. So the geometric shape that we drew is a line, but there are lots of lines out there, so I need to describe what makes this one so special. The easiest, not the only, but the easiest way to describe him is to say that he is the perpendicular bisector of the line segment that joins the two given points. All right, at this point, if you have any questions, like always, either feel free to shoot me an email or write them down so that you don't forget to ask the next time that you come back to class. And when you come back to class, we're going to be working more on locus. In fact, we're going to be working with compound locus and putting a couple of these together in the same picture.